Okay, another question that I find students have a lot of trouble with is this one here. So here you have two masses, okay, one is horizontal on a table, one is suspended vertically, and obviously gravity is pulling this one down. Let's see, the block is connected by a cord passing over a pulley, so we're assuming there's no friction. Assume the cord to be light, so there's no mass to the cord, and unstretchable, so if this one's falling, this one is moving to the side. So pretty much what that's saying is all you need to worry about is the two forces there. So seeing as your questions are all different, I am not going to actually solve this one. I'm just going to help you set it up. So we want to calculate the acceleration of the first block. So here, let's do that. So I'm going to draw this. I have my table here. I have my first mass up here, and that is passing over a pulley down to a second mass here. Now, pretty much in physics, you always want to remember that force is equal to mass times acceleration. This is going to help us tremendously. Okay, so my force is equal to mass times acceleration here. Seeing as these are connected by a string, they are going to be moving at the exact same rate. So here I can say my force is going to be the sum of my masses, m1 plus m2, times whatever acceleration they have. Okay? But seeing as m1 here, my first mass, is just along for the ride, it's not really contributing to the force. It's actually just kind of slowing m2 down. My actual force here is going to be m2 times g. This is the only thing that's pulling on the string here. It's pulling downwards, and it's attached to this. So this is one way of representing my force here, m2 times g, and another way of representing my force is this total, my two masses times the acceleration. So because my force is the same, I can make these two things equal to each other. So here, if I have m1 plus m2 times my acceleration, that's going to be equal to my second mass times my acceleration due to gravity. And here you can actually solve for this question by isolating acceleration here. So if I divide both sides by this, now this part would probably be easier if you did it with the numbers, plus m2. My acceleration in the end for whatever numbers I have would be my second mass times gravity divided by the sum of the two masses. This is in general form, but as you can see, these two forces are equal, so if I make them equal to each other, I can solve for acceleration there. Hope that helps. Keep on going.